Okay, so in this video we'll talk about the concept of limiting reagents, which is a very important chemistry in your study of O-level chemistry. So what is a limiting reagent? So let's suppose here you have a reaction between an acid and a base, which is between hydrochloric acid and calcium carbonate, which is your base. You should remember the general equation for this type of a reaction, that when you react an acid with a carbonate, you get a salt, carbon dioxide, gas, and water. So this is an example of a neutralization reaction. Okay, so let's suppose you had this reaction taking place, and you had your acid in a flask like that, and you drop in your calcium carbonate solid. Then you're supposed to see carbon dioxide gas fizzing off. It's one of the observations that we see, and gradually your calcium carbonate is going to dissolve, and eventually it will all dissolve such that you do not see any bubbles of the gas coming off. So at this stage you will know that all my calcium carbonate has been used up. So in that case, if you are so sure that one of the reactants has been used up, so the reactant that would have been used up is what we term the limiting reagent. It is the one that brings the reaction to a halt. So your calcium carbonate in this case would be limiting. So that is what we mean. The reactant that is used up first is what we term the limiting reagent. Okay, it is termed the limiting reagent here in this case because it determines how much of the product is formed. So the carbon dioxide that is coming off that reaction depends on how much calcium carbonate is present. So if you added more calcium carbonate, for example, once your reaction is stopped, if you added more calcium carbonate, then more carbon dioxide will be formed, meaning that the amount of carbon dioxide formed depends on the calcium carbonate. So once we have identified our limiting reagent, then the other one that is not used up first is the reagent that is in excess. So it is called the excess reagent. Okay, so let's see what would happen if you added more of the excess reagent. Nothing would happen. So nothing happens when you add more of the excess reagent. Only the limiting reagent determines what would happen. In this case, the reaction would continue. Okay, so in calculations, you can be told that one of the reagents was in excess, or it can be implied in the question. So, for example, calculate the mass of sodium oxide produced when 115 grams of sodium is burned in air. So, in that case, we know that air contains oxygen, and this would be the air around us, which is the atmosphere. So the oxygen must be in excess because there's a lot of oxygen in our atmosphere around us. Okay, so in that case, only sodium can be limiting. Okay, so let's look at a specific example here. What you need to do is you have to create the equation and balance it. We saw about this when we talked about the law of conservation of mass, that you must balance out the atoms that you begin with must be exactly the atoms that you end up with. So if you balance out that, you are going to have 4 moles of sodium reacting with 1 mole of oxygen to give 2 moles of sodium oxide. So what's important for you to know here is the number of moles that you are asked here to calculate the mass of sodium oxide produced. So you want to know the number of moles that you start off with, for the sodium. So how many moles did we start off with for the sodium? So if we do the calculation here, we know that a number of moles is equal to mass over mR. So our sodium has a mass of 23, and the sodium that we begin with is 115. So that means we start off with 5 moles of sodium. So if you look at the ratio of the sodium to the sodium oxide produced, you see that there is a ratio of 4:2, which can be simplified to a ratio of 2:1. So that means that every time we have 2 moles of sodium, we produce 1 mole of sodium oxide, meaning to say we produce half. So when we have 5 moles of sodium, we're going to produce 2.5 moles, because that is half of 5, 2.5 moles of sodium oxide. So we now need to convert the moles that we got of sodium oxide to mass. So we need to rearrange the equation and make mass the substitute formula such that it becomes mass is equal to moles times mR. So moles is 2.5, or mR for sodium oxide is equal to 2 times the mass of sodium, because we have 2 sodium atoms, plus the mass of oxygen, and this gives us an mR of 62. So if you say 2.5 times 62, you get 155 grams. So in summary, this is what you would do if you were asked to calculate the amount of a product formed given the amount of a reactant. And you should start off with the balance equation, and you use the molar ratio. It is also important for you to calculate the number of moles of the reactants that you begin with. So we're going to look at a different situation where you are asked to identify the limiting reagent. So I'll see you in the next video, where we're going to do more calculations that involve limiting reagents.